think it'll be interesting for other people to hear about these theories that you have. Okay, so one of them is the theory about the ball. If you set a ball into motion in space.
Yeah.
What was that one?
So,
or not, that's not your theory. It's just something that you told me. I think, yeah.
So if you, let's say, have a bouncing ball, let's say, and then you were in space, like not on the moon, not on any planet at all, purely in space, and you threw it as hard as you could. That ball would keep on going and going until it hit another planet with gravity, or until it gets burned by a star or something, because there's no friction in space. Because if you throw a ball here, the gravity will make it go down, and then the air is friction.
Oh, so, even the air.
Yeah, that's why if a meteor comes down, it catches on fire because of all that friction. It's like rubbing your hands together like this.
But where's the friction
like
in the air, though?
Friction is when it's bumpiness, okay?
But bumpiness from what?
We do this, okay? We can do this and we don't feel anything. But
there is friction even when we do that?
Yes, because we're going through something.
Through what? Air?
Yes, through
or
air.
Through gravity?
We're slashing through air, okay? And the air is grinding on us when we do this. Do you feel coolness in your hand when you do this?
Yes.
Yeah, that's air, all right? You're breaking through air. You're causing a vacuum when you break through the air, which is no air at all in there.
Oh, I'm causing a vacuum?
Because the air has to go back. It's like lightning. Once the lightning goes down, since light travels faster than sound, the thunder, you see lightning first, and then the air has to come back in, right? Because the light is like smashing through the air. Okay?
Oh.
And then the air comes back so quickly that it just causes a big boom.
The air kind of regroups after the lightning smashes through it. And that's what causes thunder? The air smashing into the other air? Oh, okay. Wow. So air causes friction in our atmosphere. That's what you're saying. And then what you're telling me is, in space there's no air?
Yeah, in space there's no air and no gravity. Gravity causes the ball to go down, okay?
Okay.
And when it goes down, it's going to hit friction, the ground. If you do this, which is faster, doing this or doing this?
Doing that, the second one.
Yeah, because the air has less friction because the molecules are less tightly packed.
Than the bed.
Yep.
The air has less, okay, but the air does have friction, just less than the bed. I see what you're saying. Okay, good. Okay, so the ball, so what you're saying is, in space, because there is no friction, due to having no air,
and no gravity.
No gravity. If I throw a ball, it'll keep going and going and going. The same speed, will it start going faster?
It'll go the same speed as long as it doesn't meet any gravity or air.
And the gravity would probably be like a black hole, another planet, something like that.
Yeah, or the sun, or space orbiting. If you threw it in our
atmosphere?
In our solar system.
Yeah.
It would not be going the same speed because the sun's gravity goes all the way down to Pluto. So until the ball passes Pluto, it's going to be going the same speed because of the sun's gravity. And the sun's gravity might even go much farther than Pluto.
Okay.
So, because the sun has such an immense area of gravity that it's hard to go against.
So what does that mean for the ball? If we throw it within our solar system, will it
would still keep on going for much longer than we can throw it here.
Okay.
But it would eventually stop because of the sun's gravity, unless it surpasses the sun's gravity. Then it would keep on going until it reaches another star's gravity or another planet's.
Okay. So the original rule of if we throw the ball, it'll go the same speed for until it hits. That has to be outside of our solar system because
it
we
has
have
to be outside of any gravity whatsoever.
this, including our sun's gravity. Okay, I got it. Okay, so within our solar system, it would stop eventually. Outside of our solar system, no, until it hits another star. I got it. Okay, now can you tell me the theory about? Okay, you were telling me black holes, a lot of gravity, but you think that if we could build a machine, like a rocket or something, to travel faster than the speed of light, somehow
no,
we
not
could.
faster than the speed.
Okay, tell me that theory about the.
So, first off, a black hole and light. Okay, if you somehow divided the black hole's gravity, the same way you divide.
Because a black hole is gravity, right? That's all it is.
That's all it is.
It's a big pocket of gravity.
Yes, it's just this big circle of gravity that is like 1,000,000 more times than the Earth. So, let's say you have light, okay, and you divide its speed into some sort of measurement, and let's say that measurement is 54, okay?
Okay. You're just making that one up, though, right?
Yeah,
okay.
I'm just making it up. And then you divide the black holes and by the same fraction. So, like, let's say you divide light's speed by 1/8. You would have to divide the gravity of a black hole by 1/8 as well. And then the number, the black hole's number will be greater. I am positive, I am 100% sure that it will be greater because the black hole
Greater than what? I'm lost.
Greater than the light's quotient, okay?
Equation?
Yes, greater than, because you're dividing here, so it's a quotient.
But oh, the quotient. It would be
Yes.
greater than the.
The black hole's gravity's quotient would be greater than light's speed quotient, okay? So,
Okay.
because light bends toward gravity. You know how light spread, if my hand was light, okay, it would go backward, sideways, and forward, right?
Okay, hold on. So if my hand is in the center of a pocket of gravity, you're saying the gravity will pull it from all directions, forward, backward?
No, not at all.
Oh, not
My
at all.
hand,
Okay.
Arrows all around me. No black holes yet.
Okay, got it.
So my fist is the sun, okay?
Okay.
It emits light every
Oh,
which
okay.
way,
Right. All around.
Black holes would cause sun's light to bend toward it, so it wouldn't be going here anymore. It would be going here if the black hole was here.
Oh, right.
Fist
Right.
Is sun.
Yeah.
So here's the light, and then it would just bend to the black hole.
Okay.
That's how much gravity that the black hole has.
Okay.
So, if people could invent a machine that somehow sends out a sort of gravity, like a ball of gravity, for example, like a black hole, for instance, and then the vehicle would be going toward it, right?
Okay.
Because gravity likes to suck things in.
Yeah.
So, when it does that, then it would keep on going faster. So they would have to time it just right. So if you start at 0 kilometers, 0 miles per hour,
Okay.
and then it sends out this hole of gravity, then you go there,
Okay.
and then it stops. Okay. So you're in the air. You just start on ground. You go into the air. Okay. Then it stops. Well, you're still going to be going that speed if you're in space. Okay.
Right.
This can only work in space, though. In here, it'll be like
Because
the thing will stop, fall down. Okay.
Okay.
But in space, that's the same as the ball theory. If you throw it, it won't lose its
Momentum.
Yes. So it would be the same with this machine. So they would have to time it just right so that it'll stop and shoot another one. The gravity
Maker?
shooter
The gravity shooter.
would suck it in and then shoot it out again, okay?
Okay.
And they would have to time this just right. They would have to program it so that it goes, like let's say it lasts for 5 seconds on the first one, then 2.5 on the second one, and then one.
But why? Why not just shoot it once?
Because then then the gravity, because of the ball of gravity, it works the same way as light does. It likes to go in all directions.
Right.
Forward, backward, sideways. So your machine would be going as fast as that ball of gravity, correct?
Yes.
If you commit those two numbers. So it would be going forward as well. So if you use that gravity to speed you up going this way, and then you go over here, what will happen to this gravity? It likes to suck things in, right?
Oh, it's going to suck you
So
back.
It would make you go slower.
Oh,
So they
yeah.
need to time it just right so that if they want to go as fast as light, as quick as possible, they would have to time it just right to make it stop so that you get the maximum effect of gravity, but you don't go overboard.
Right. So meaning that you're going to slow down and get pulled back, or even get pulled back.
Yeah.
Mm-hmm.
So you would have to time that just right and then shoot another one out, okay? To keep on going and going. And the program of that machine would have to be like, keep on getting shorter and shorter and shorter. So then eventually you'll be going as fast as light. So once when you're going as fast as light, and in space you won't have to go any faster, and I don't think they could program it to shoot it faster, as fast as light, okay? So you would have to find a black hole, okay? This is for like traveling as far as you can.
Okay.
You would have to find a black hole, okay? And like I said, of light's numbers and the black hole's numbers. So if you go toward that black hole, well, you'll go faster, because if you pretend you throw a ground, pretend I throw a baseball right down toward this bed, okay? How fast do you think that'll go? Maybe 15 miles per hour?
Maybe.
So,
maybe.
What would happen if you chucked it from a helicopter 125 miles above ground?
Oh, it'll go
something?
faster by the time
Yeah, it'll
it's
be
closer,
like 100
right?
miles per hour,
Oh.
or even more.
Okay.
So that's why gravity has an effect on speed, and there's no friction.
Makes it go faster the further it goes, right?
So if
Okay.
you were heading straight toward a black hole, okay, light would be at its fastest speed because it's in a vacuum with no air, so that means no friction at all.
Light is at its fastest speed right before it reaches the black hole, after it reaches the black hole, or when?
When it's approaching.
When it's approaching the black hole.
When it's an atom away from reaching the center of the black hole. So
Or the opening of the black hole.
the center
Okay.
of the black hole.
That's when it's the very fastest it's ever going to be.
Yeah.
Okay.
And so once when it is at that point, it'll be for most things going at a fair speed. It would be ripped apart because of all that gravity. Gravity goes this way, this way. It's like angry mobs wanting to tear you apart. So you would be ripped into pieces like a million different ways. You'd be torn into a million different bits. But that takes time, right? If you were to rip paper, it would take time. So you can't do that instantly. So
Okay.
if you take light speed then, when
Okay.
it's an atom away from that black hole, and you take the black hole
From the center of the black hole.
Yeah, I mean from the center of the black hole. And you take the black hole's gravity and
Okay.
you divide those again by the same
Number.
fraction or decimal that you want to. Like you take 1/8 and divide that, like how
But why do we have to divide it?
to get the even number. So
Why do we need an even number?
You get that number, okay? Pretend it's 50.
But why do we need that number?
It's
Okay.
54 for light.
Okay.
And then it's 75 for the black hole, okay?
Okay.
For the first time you did it.
All right.
Now the odds are going to change. The black hole is still going to be 74. That's just going to go even. But then the light is going even faster. So that equals a greater number that
Oh, 'cause
you're going
it's-
to divide by.
Oh.
So that number would be much greater than the black holes.
Oh.
So now it wouldn't get sucked in, alright? So if you go straight through the center, okay,
Okay.
the black hole wouldn't have time to rip you apart because it's like a magnet, for example, like the strongest magnet in the world. And if I were to use it on a doorknob
Yes.
while I'm like 5 inches away, it's going to happen instantly, right?
Right.
Well,
It'll rip apart the doorknob, you mean? Uh-huh.
yeah, it'll happen instantly. But what happens if it'll rip it apart instantly? But what happens if I'm farther away?
It won't rip it apart instantly. It'll have to suck it in first. Right?
Exactly. It's going to take time to do it.
Uh-huh.
Mama,
So-
teacher has the
In
mom.
that scenario, you would be going so fast that it would be you can't even imagine how fast you would be going. Imagine how fast light is. It travels 16 times in a second from Virginia to California and back.
Whoa.
16 times.
But how does that affect going through the black hole?
Exactly. It would be going so fast that the black hole doesn't have time. So when it goes
Okay.
through,
Uh-huh.
it's going to be out. And it's still going to be going pretty fast because
Oh, because the gravity in the black hole needs a little time to have an effect on what's going through it. Oh, I see, I see.
like
Mhm.
but black hole's gravity is so high that for most things it happens instantly.
Uh-huh.
Like almost instantly.
Right.
But if you're traveling faster than that,
Then the gravity's effect. That's the key. You have to travel faster than the gravity has time to take effect. Even this
Exactly.
immense gravity, if you can
Exactly.
travel faster than its strength or the time it needs to have an effect, you can make it through without getting...
Exactly. And
Oh.
the gravity going back there won't be it will be a tiny issue for you.
Yes.
But it won't be a big one.
Okay.
Because you're gonna be going so fast that it's gonna have to take time again. So you're gonna be like past it by the
Mm. Okay.
time you know it
The effect would have started.
Effect on light.
Mhm.
Because
But could it
will
pull
have
you
an
back?
It will not pull you back. You would still be going faster than light as we know it here on Earth. It would be going faster than the sun's light to us.
Right.
But it wouldn't be going as fast as you were an atom away. But that's still
Way fast.
immensely fast.
Yeah.
Because light with friction
Yeah.
travels to Virginia to California 16 times. So imagine
In a second,
in
oh my
1
gosh.
second, okay? So imagine
the friction, and you're talking about light going through the friction of air.
Yep.
Okay.
So imagine if light is going twice as fast as that with no friction.
Through a vacuum,
Hello.
Yes, through
that'd be so
through
fast.
the vac-
Yeah.
Yes.
Wow. So, okay, here's a question for you. So,
So it would get you somewhere that you really want to go really, really fast.
so then would you end up going out of the other side of the black hole?
Yep.
Like, where would you go?
You would be
Oh,
going at the other side.
is there like an end to it? Like, is it kind of like a pocket? Like it actually has a,
It's
or
like
is there?
a sun. It's just
Oh,
a
it's like
ball.
a sun. It's a ball of gravity. Oh, I always kind of thought it had an opening and it was like more like a cave. An opening
No,
and then,
because,
yeah.
how could it travel endlessly? Because that's a dead. It's a star that's dead, and it's
Right.
so compressed. It's smaller than the sun. It's smaller than its star. It gets so compressed, but the gravity is like 10 times more than the star's gravity.
Right.
So, what black hole you would want?
Yes.
You would want the largest black hole possible because that would emit the most gravity. Like our sun
Which would
is
make
a
your,
medium
but then
size-
you'd have to go even faster. Like if you found a weaker black hole,
No, the gravity would make you go faster.
Oh, I see.
A weaker black hole,
you'll go slower.
you'll go slower than the bigger black hole.
I
That's
see.
why you want the bigger one.
Right. I see. I got it. Okay. Now, if you could ask Albert Einstein any question about space, what would your question be? Or physics or whatever.
My question would
Or say not even Albert Einstein, somebody who knows everything. Like he didn't know everything. He knew a lot, not everything.
somebody who knows like
Everything.
God.
Like God. What would you ask him
Right.
about space?
I would ask him, what is space? Because we don't know what space is. It's not made of atoms because it's just like nothing. basically
It's not air.
it's not any state of matter at all. So I would ask them, what is space?
What is that? Yeah.
Because everything, I think, is something. There's like not nothing. And like, where does space? Where what is space? In a way,
And like maybe where does it begin and end?
it doesn't begin and end anywhere. It's endless.
It's endless. That's kind of wild. But how can it be endless but it's always growing, expanding? How can it be endless and expanding at the same time?
Think of it exactly. That would be part of my question. Like, what is space? So that could be like a state of matter. What's the purpose? What is like?
How does it expand?
Yeah.
Yet
How does it do everything? If you say, what is water? People could say 1 atom of oxygen and 2 atoms of
hydrogen.
So people they could say that, but you could say no, but that's not the answer that I want. I mean, like, what is its use?
Oh, okay.
And they would answer that like, oh, it fills you and stuff for water purposes.